to SciTech. This video is going to be a tutorial on electronics. I'm going to show you the basics of electronics and show you what each electrical component are, what they do, and how they work, and how to use them in a circuit. Let's get started. I have right here an LED, 2 jumper cables, a 1K ohm resistor, and a 9-volt battery. And I have also these alligator clips that connects to the 9-volt battery. This is a breadboard, and what a breadboard is actually a solderless circuit board. It allows you to prototype your circuits and allow you to test your circuits to see if certain configurations work and to do experiments with. This is a breadboard diagram. As you can see, the whole blue line is connected, the whole red line is connected, and the whole blue line represents negative, and the whole red line represents positive. And then on the center part of the breadboard, where you see all the green lines, each row of the green line that's connected is the rail that's connected, and then the space in between separates them. And you use these pins here to connect your components into to test them out. Let's go ahead and do a little experiment with that. And here's the breadboard. Now let's go ahead and take a positive wire and connect it to the positive rail of your breadboard. Let's go ahead and take your negative wire and connect it to the negative rail of your breadboard. And connecting these two wires allows you to power the breadboard in that row only. Now I have my negative alligator clip to connect to the negative rail. And this connects to the negative terminal of your battery. And the same thing again with the positive. And this is an LED. LED stands for light emitting diode, and it's basically just a small light. Allow me to explain it a little bit further with this diagram. This right here is what the LED looks like in the inside. On the left is positive, on the right is negative. The one with the positive, you can see the leg is longer and the piece inside of the bulb is smaller. And then on the right, where it's negative, the piece in the inside is bigger and the leg is shorter. That's how you can identify the positive and negative of the LED. Now, the technical term for positive and negative is positive is anode and negative is cathode. And an easy way to remember the two differences is I remember it by using a woman's name. For example, positive is anode and the name is Anna. Anna is always positive and happy. And negative, which is cathode, and the name would be Kathy. Kathy is always negative and angry all the time. And that's just my easy way to remember the difference. A little bit funny, but it's a good way to remember. So let's go ahead and test out this LED. Now I'm placing my LED on the breadboard, and I have right here a resistor. The resistor I'm connecting to the cathode of the LED, and I'm connecting the resistor to the negative rail of the breadboard. Now you may be asking, what is a resistor? A resistor is an electrical component that resists the flow of current. For example, if you want to take 9 volts and reduce it to 3 volts, you use a resistor for that. And how do you know how to do that? Well, as you can see on these bands, you can identify it by using these colors. And each of these colors represents the value which you see these stripes that's on the resistor. So you calculate with these stripes and it adds up to a certain value. And it's a measurement. And the measurement is called ohms. So you have ohms of resistance. Now let's take an example. This resistor here. What's the value measured in ohms in this resistor? Well, you have red, black, red, and gold. Well, red, black, red, which will be red is 2, black 0, and then red again, which is 100, which is the multiplier. So that should be 2000. So that'll be 2000 ohms. And that gold band is actually called the tolerance, and a tolerance shows the percentage of how accurate that resistor is. So that's basically what a resistor is. And in a future video, I'm going to make a video about just resistors, just LEDs, and just other electrical components where I explain full detail of the actual individual component and even give the mathematical meanings of each of these components. But for now, I'm just showing you the basics of how to use them in a circuit. I'll explain better details in these future videos. So let's continue. Now let's go ahead and take this jumper cable and put it into the anode and then connect it to the positive rail. Now you can see how this resistor works. And there you have it. Now if I were to plug the jumper cables in directly without the resistor, that LED would actually burn out. So that's why you use a resistor to reduce it down to 3 volts. Now this here is a push button switch. I'm going to show you how to use a simple push button switch. Now you can see these 2 legs are what you need to connect to. So now I have the one leg connected to the anode and one leg free on the breadboard. So I'm going to go ahead and take my jumper cable and connect it to the other side. Just like that. And now connect it to the positive rail. LED is not on until I close the circuit by pressing down on the switch. And there, the LED turns on because I closed the circuit. Open circuit, close circuit. Open circuit, close circuit. Open circuit, close circuit. See, it's that simple and that easy. Now let's try another electrical component. This is a capacitor. A capacitor is an electrical component that stores electrical energy, just like a battery, except it stores the energy and releases energy and is measured in farads. And as you can see, this is 100 microfarads, which holds a very little amount of capacitance, and it can release it quickly. And at 50 volts is the maximum amount of voltage this particular capacitor can take. Anything above it could cause it to explode. And as you can see, this gray line that shows negative is actually the negative side. And on that side that doesn't have it is the positive side. So now you can tell the difference between the 2 leads of which one's positive and which one's negative. So let's go ahead and put it on the breadboard and test out what it does. So I'm putting the jumper cable attached to the negative terminal, putting it into the negative rail, and now I'm going to close the circuit by pressing the switch, and look, it stored the charge and the LED doesn't turn off immediately. The LED stays on for a second. That's because the capacitor took in the charge from the battery and it's slowly releasing it. Now let's try another capacitor. This one is 200 volts, okay, that's good. But this one is 10 microfarads. What's going to happen if you connect 10 microfarads to this circuit? Capacitor charges, oh, and the LED doesn't stay on as long. See? The LED stays on less than 100 microfarads. So if you're using 10 microfarads, it holds even less capacitance, so the LED stays on less time. Now let's try 1000 microfarads. Now let's see what happens when we charge this capacitor. And the LED stays on much longer. That's because this capacitor holds more capacitance, which means it holds more electrical energy. So the LED stays on longer. Charging it for a long time, and the LED stays on and goes off. Takes less time for it to go off. So there you have it. That's how a capacitor works. Now let's go ahead and try another electrical component. This here is called a variable resistor. Just like a resistor, except you have a knob which you can turn. So you can turn the knob for high resistance or turn the knob for low resistance. The easier way to think about this, it's basically like a dimmer switch. When you turn your lights on low or turn your lights on high, it's the same thing. Now let's go ahead and plug in the variable resistor. You plug in the far left pin and the center pin, or you can plug in the far right pin and the center pin. It depends on how you want to turn this variable resistor on. Now as you can see, I'm turning the knob to the left and the LED turns bright, which means there's less resistance. Now I'm going to go ahead and turn it to the right, and there you can see the LED is dimming. That's because there's higher resistance. Let's try that again to turn it down to lower resistance. And now the LED becomes brighter. This is a very, very useful component to use if you want to be able to control the amount of resistance in your circuit. Now let's try another electrical component. This is an RGB common cathode LED. And what this is, it's an LED that lights up in 3 different colors: red, green, blue. That's what RGB stands for. And common cathode means that it uses negative terminal, which is the longest leg. And the one right here on the left is the same thing, but except this one is a common anode. Both of these LEDs work slightly different from each other, so the configuration of putting these in the circuit is a little bit different. But they both work the same way, where they light up in a red light, green light, and blue light. It's just configured differently. So let's go ahead and try this out on the breadboard. Plugging in the RGB LED common cathode. Now with the common cathode, you connect the resistor directly to the cathode of the LED and plug it into the negative terminal. Now let's go ahead and use these switches. Plug in the jumper cables to all the leads for the different colors and attach to the switch. And now plug in the other jumper cables to the switch to plug into the positive rail to power the LED. Now let's go try it out. Red LED turns on. Green LED turns on. Blue LED turns on. And there you have it. Very simple. Now let's try the RGB LED common anode. So you plug it into your breadboard just like that. And you use 3 1K ohm resistors. Now you connect the resistors to the cathodes of the LED. And connect the anode to the positive rail. And connecting the resistors to each of the cathodes of the LEDs, all of those cathodes are the actual colors of each individual LED that's inside of the RGB. And this one being a common anode, you can see that it's configured differently than a common cathode. Needing to put resistors on each of the cathodes allows this to work. It prevents the LEDs from each of those pins from burning out. I don't know why it works like that, but it just does. But yeah, there you have it. Red, blue. And there you have it. This is how an RGB LED common anode works, by attaching the resistors to each of the pins. Then you press the two together, and it does light up in a sort of a violet color, but it doesn't come out so clear, in my opinion. Sort of a turquoise color, and sort of a yellow color. It kind of works, but in my opinion it doesn't work as well as you would expect it to by turning each of the LEDs on at the same time in different colors. As you can see, turning all three of them on, you'd expect a white light. Sort of does that, but it still has a bluish tint to it. Thank you for watching my video on basic electronics. And thank you for watching SciTi Tech. I hope you learned something new, and don't forget to like and subscribe for more SciTi Tech videos. Till the next tech, goodbye.